review 6.5. I put about 12 questions. Now it says we're recording. Okay. All right. So I think we're recording now. So I'll restate what I was in the middle of saying. I just posted the review 6.5 about 15 minutes ago. Sorry that was late, but you had plenty of stuff to review anyway, right? So this will be your last thing. And plus we just did it, so it should be easy. So who wants to start us off with a question?
Oh, I will most happily go.
Most happily.
Should we just
You're
start
back
on
in
review
your car
2?
today. They didn't open up the bank for you.
No, not quite.
All right.
So on review 2, I thought we just go in order. So number. Oh, I was
go ahead.
So it's number 33. So I don't know why this one was confusing to me because I understood it in the review, but obviously 2 weeks is a long time. So
review 2, question what?
33.
33. Just says solve the problem. Okay, so where is my share button? Okay. So it says solve the problem, and we've got this nice triangle here. We can angle theta, find the exact value of the tangent of 2 theta.
So the tangent of theta is 8/15.
Okay, opposite over adjacent, okay.
Mm-hmm. And so are we just going to put it into the equation? So
we've got an identity for tangent of 2 theta, right? Yeah. What's that identity?
2 tangent of theta over 1 minus tangent squared of theta.
Okay. Okay, so the tangent of 2 theta, I'll use t for theta, equals, say it again?
Isn't it over 1 minus tangent squared of theta?
1 minus tangent squared of theta?
Oh, sorry. So tangent of 2 theta is equal to 2 tangent of theta over 1 minus tangent squared of theta.
Okay. And we know that the tangent of theta is what again?
8/15.
I'm going to write that as 8 over, here I'll write it this way. 8/15. Okay. All right, so if we plug that into our formula, this becomes 2 times 8/15, which would be 16/15.
Mm-hmm.
And then over 1 minus the tangent squared of 8/15.
Mm-hmm.
I'll write it this way. Now, the problem is we're trying to get it in their dumb form here. So, well, we know, okay, so we could do, so this is actually, if I rewrote the denominator, 1 minus 64 over 15 squared is 225, if I remember right. Does that sound right? I think it is. So, so that's equals 225 minus 64, which is 161. So basically, I've got 16/15 over 161 over 225, right? So I can flip those, and that's going to give me 225 over 161. The 15 is going to go into there, so I'm going to end up with 16 times 15, which is 240 over 161.
Okay.
Does that make sense?
Yep.
So where did you get messed up? You remembered the formula. That was the hardest part, wasn't it?
I don't know. I guess I just got a little confused overall, but it's all good. That makes sense now.
Does it make sense? Okay.
Mm-hmm.
Okay. Are you impressed that I remembered the 15 squared was 225?
That was pretty impressive.
Okay. You know how I learned that?
How's that?
My trig teacher. Well, he was also my college algebra teacher and my calculus teacher. Oh, this is a weird story. I got two weird stories. Number one, he made us memorize all of the squares from 1 to 30, and I still remember some of them. I remember 30 squared is 900. That one's easy, but the other ones I can't remember very well. But 15 squared I remember because that one you use fairly often. Number two, I went out with his daughter in college, and then when I found out who her dad was, I'm like, I can't date you anymore. But here was the weird thing. Number three, I went and graded the AP statistics exams in Kansas City last year. And they had a special church service for people who wanted to go. And he was there grading the calculus exams. And I was like, oh my gosh, this is pretty weird. So anyway, yeah, still have nightmares from my trig teacher. So what other questions do you have?
I would number 30.
30?
Yeah,
Same
I just
review.
wasn't exactly sure how to approach this one.
Okay, determine whether the positive or negative sign makes the equation correct, and do not use your calculator. Okay. So, anybody have any ideas? Don't all speak at once.
Oh, is this the one that was written wrong? It's either the denominator on the left is supposed to be 8 or on the right it's supposed to be 5. Because that's supposed to be a half angle identity, right? And negative 3 pi fourths isn't, or negative 3 pi tenths isn't half of negative 3 pi fourths. I feel like I remember that one being a typo.
Well, whether it's a typo or not, we should be able to tell whether it's positive or negative, because we're not actually asking to solve it. But yeah, I kind of think you're right. It probably is a typo, but I don't remember making that typo. But anyway, either way, pretending it's not a typo, is it positive or negative, and why?
Is it negative because it's in quadrant 2 for cosine, or no? I have no idea.
Well, let's draw it. Okay. So the tangent of 3 pi tenths, negative 3 pi tenths, is definitely going to be in quadrant 4, right?
Mm-hmm.
Okay. Now, let's think about this. I think you're right. It should be 3 pi fifths, right? Not 3 pi fourths. That's kind of weird. I'm surprised. But 3 pi fourths, negative 3 pi fourths would be where?
It'd be in the third quadrant.
Maybe second quadrant?
Well, it would be the second quadrant if we measured it in the positive direction. But it would be in the third
Okay.
quadrant if we measured it from the negative direction, right?
Yeah.
Okay. By the way, I don't think I ever taught you guys this. I taught you that all students take calculus, right?
Mhm.
That was from
Yeah.
Larry, my trig teacher. But there's also a saying called SOHCAHTOA. Have you guys ever heard of that?
Yep.
Mhm.
SOHCAHTOA. I thought that would come up here. All right, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if you want to remember that. But anyway, all right, so if we're measuring it from the negative direction, yeah, this is going to be here. So the tangent's going to be negative in the quadrant 4, and the cosine, let's see, the cosine is also going to be negative. Let me think about this though. Yeah, it's still going to be negative, so it's going to be negative. Wait,
So
you
it's
can't
based-
take the square root of a negative number though. Let me think about that. Let's see, but this is negative. So if this is negative, 1 minus a negative makes that positive. And that should be less than 1. Positive over, yeah, that would be positive. So it would be positive. So it would have to be positive, right? No, it's got to be negative.
You seem self-conflicted.
Was that a question? So just don't have a question like this on the test, and then we're good. Yeah.
Yeah, don't have one like that. Yeah, well, it won't be multiple choice, so there you go.
Well, just don't have one then. You only have 15 questions. There's a lot of other information on
But
there.
the thing is, we're talking about the tangent of this number, right?
Mm-hmm.
Well, the tangent's got to be in quadrant 4, and the tangent's got to be negative, so it's got to be negative.
So it's based on the tangent. That's what we're looking at, positive or negative.
Right. So we're doing the tangent of a negative angle, and because it's a negative angle, it's going to put us in quadrant 4.
Okay.
So that's got to be a negative value.
Okay. Gotcha.
Okay.
Thanks. Okay.
All right. Any others?
Can we do 34?
34. Given the following information, find the exact value. Okay. So the cosine is negative and the sine is positive. Find the cosine of theta over 2. So how would we do this one?
I've got all the work on my paper, but I don't remember how to do any of it. So, well, I know
What do you have
that
on your
it's a.
paper that might
Oh, I've got a
Here, I'm
3,
going
4,
to
5
erase these two
triangle.
things. It's a 3, 4, 5 triangle. That's going to be very useful, right?
Yep.
Now, okay, so let's talk about this for a minute. Okay, so it's a 3, 4, 5 triangle, which is really helpful. And the cosine is negative in both of these quadrants, right?
Yes.
And the sine's positive. Well, the sine's got to be in this quadrant, right?
Yep.
So therefore, it's got to be in quadrant 2, right?
Yes.
Now, if this is theta here, where does the 3, the 4, well, the 5 goes on here, right?
Yep.
Where's the 3 and the 4?
The 3 would be on the bottom, and the 4 would be on the left. Or yeah.
So -3 and +4. Okay. Now, were you able to figure out that it was in quadrant 2 on your paper?
Yes. Yep.
Oh, okay. Okay, so now that we know this, when we've got the cosine of theta over 2, what's my half angle formula?
Oh man. I don't know. I can't remember what it was. I haven't reviewed it.
Uh-oh, that's something we need to review. Who remembers?
Plus or minus the square root of cosine or oh shoot. Oh man. I did it when you're about to say you forget.
Because you need to know this for tomorrow.
Is it the square root of 1 plus the cosine of theta over... Oh, Corey, help me out. I can't remember what the
And then
denominator is.
cosine of theta over.
We need to look it up.
Oh man, we were so close.
It's 1 minus cosine over 1 plus cosine of theta. I looked it up.
Thanks, Nicole.
No problem.
Okay, and the square root is over the whole thing, right? It's kind of like the one we just did, right?
Yeah.
With the tangent.
Yeah.
Okay, so 1 plus cosine of theta. Okay. All right. So cosine of theta negative 3/5. Okay. So when we're doing this, we're going to get the square root of 1 minus negative 3/5, which is really 1 plus 3/5. That's a problem. Well, let's see. Yeah, it's a problem because we can't have a number greater than 1. Oh, no, it's okay. We can.
Wait, hold on. I gave you the wrong equation.
Yeah,
It's
she
over
did.
2. Yeah, that's my bad. I was looking
Yeah.
at tangent.
So the cosine of theta over 2 is plus or minus the square root of 1 plus cosine of theta over 2.
Yes.
Yeah, I thought it was.
Yep. Now we're right.
You looked it up.
No. 1 plus cosine of theta over 2.
Yeah.
Oh, theta
Because
over
it's our
2.
half. Or no, the denominator is 2. Because we're taking the half of the theta. I thought.
This whole thing.
Yeah.
The whole thing is 2.
Take that away and put 2 there. Perfect.
Okay, because it's not the tangent. You were looking at the tangent. Okay, so all over 2. And your square root, right? Are we good?
Yes, that is now good.
Okay. So 1 plus 3/5 is 8/5 divided by 2 is 8/10. So this is going to be the square root of
Is
8
that 1
over 10.
minus 3/5 now?
Huh?
1 minus 3/5? Or is it 1 plus?
Yeah, because it would be 1 plus a negative 3/5.
No, oh yeah, it is. That's right.
So it would be 1 minus 3/5 over 2.
Okay. So that's 2/5 divided by 2, which is 2/10, which is 1/5.
1/5.
Okay. Of course, the square root of 1 is 1. And so then that would be the square root of 5 over 5.
Sure. That makes sense.
All right. So that would be answer A. Which would make sense because half of theta would be in quadrant 1. So it's got to be the plus, right? Does that make sense, Jackson?
That was me, but yes, it makes sense.
Oh, Graham. Well, we want to make sure it's good with Jackson too.
Yeah.
Okay. I can't see it when you guys nod. Unless I go to full screen. You good, Jackson?
Yeah.
Okay, cool. And Graham's good. Okay. All right. Well, that sounds like we need to work on those identities again. Cameron, you got them all? We only have one Cameron today. Oh, no, we don't. We got two. Both of you got them down? One's a yes, one's a maybe. Okay. What else you got?
Number 46.
46.
I'm just choosing a random problem so I can work through it. Since no one's speaking up, so.
Oh, well, Ivan would want to do this one. Where's Ivan today? He loves these word problems. All right, this is for Ivan, even though you're not here, Ivan. I hope you're feeling okay. Water wheel rotates to the angle theta with the water level L behind the wheel changes according to the equation L equals 1 minus sine of theta minus 2 cosine squared of theta, where L is measured in inches. Determine the values for theta for which the water level is 0. Find exact values. Do not use your calculator. So how do you do this one? I'm going to copy the equation. Hopefully. That copied really well. Except for that's a squared. Not a 2 theta. Okay, so what do you think?
I'm having a hard time understanding what it's asking. Could we draw a picture of it?
Well, it just says determine the values for theta for which the water level is 0.
So L
So
is
what does
0
that mean?
Oh, so we just plug in 0.
Plug in 0 where?
in L.
In L, yeah. So it's the same equation. So it equals 0. Bang. So now it's just an algebra problem.
So you subtract one over to the other side?
No.
No.
You want it to equal 0. That'll make the problem easier.
Oh.
If you subtract the 1, then it's going to be harder.
Substitution kind of thing with this?
A U substitution with an identity might be helpful. What identity would be helpful?
It's a good question.
Because it would be nice if they were all sines or all cosines, right?
Yep.
So can we do that?
Cosine squared of theta is 1 minus sine squared of theta, isn't it?
Thank you, Graham. That's perfect. Okay, so I'm going to write it this way. 0 equals 1 minus sine of theta minus 2 times, and say again that formula, or that identity?
1 minus the sine squared of theta.
1 minus the sine squared of theta. Okay, so I can distribute that 2, right? So I've still got the 1 minus the sine of theta minus 2 minus
Oh, plus,
2
technically.
plus, right, yeah, plus 2 sine squared of theta.
Then can you just combine like terms?
Now we need to combine like terms. So 1 minus 2 is negative 1, right?
1.
Negative 1 minus the sine of theta plus 2 sine squared. Oh, this is annoying. Of theta. I still got my 0 equals. Okay, now can I factor this? Or maybe I should rewrite it this way. This might make it easier to factor. 2 sine squared theta minus sine of theta minus 1. All I did was rearrange the order.
Could you then do like a U substitution? Because I mean, it just looks like that to me. It looks like it's just like a trinomial that
Yeah.
you could factor, but
So let u equal
the sine of theta.
sine of theta. And so therefore we've got 2u squared, right? 2u squared plus u minus 1. So that factors into what?
2 and negative 1.
And u. And then it's got to be, is it negative 1? And plus 1? Make sure that's good. So that gives me 2u squared. A minus u plus 2u is plus u. And then, yeah, that works. Okay. Equals 0. So 2u equals 1 or u equals minus 1, right?
Mm-hmm.
Okay. So this could be u equals a half now. And now we need to substitute back. So sine, ooh, what happened? So sine of theta equals 1/2 or sine of theta equals negative 1.
Sine
Right.
of 1/2 is pi thirds.
So
No, sorry,
theta
pi sixth. Oh,
pi
pi
6,
sixth.
right? And theta equals
3 pi fourths. Or not 3 pi fourths, 3 pi halves.
3 pi halves. Bing. And the question is, do we need to put all those k's in there? I'll have to look at that one. 46. Oh, how did they get that?
I think it's between 0 and 2 pi.
Yeah, but those are the only ones, right? How'd they get 3 in there?
Isn't it negative 1/2 and positive 1 for the solutions?
Yeah, it'd be negative 1/2. But I mean,
Did I factor it wrong?
No.
2u squared
five,
minus
six
u
is-
plus 2u is plus u. Negative times positive is a negative. So 2u equals 1, u equals 1/2. Or u equals minus 1.
Isn't
When
it
I did it,
option
I had
6
those.
where you did it should have been 2 sine theta plus or minus sine theta minus 1 when you were translating it or changing it?
I copied that directly from the thing. So 1 minus, then I got minus 2 times 1 minus sine squared.
No,
so negative.
No, I think she's talking about line 6.
Yeah, so line 6. It should be 2 sine of theta minus sine of theta. because above it it's -1 minus sine of theta.
Oh, yes, I screwed up my sign there. That's why. Yep, I did screw up my sign there. Okay. So then that changes this to u plus 1 and u minus 1. That changes everything. Okay, so then this is u equals 1, which now makes that pi halves. And this is going to be -1/2. So sine of theta equals -1/2. So do I have my thing here? So sine is negative in quadrants 3 and 4. Okay. So therefore, this is going to be negative pi sixth. If we're doing that from 0 to 2 pi, so negative pi 6 would be the same thing as t equals 11 pi 6 in quadrant 4, and it would be 7 pi 6 in quadrant 3. Okay, so don't mess up your sign. That messed up everything. Okay, was that Cassie that saw that?
Yes.
Good job, Cassie. I feel bad you don't have a camera, but I'm glad you have one for the test. Okay, what else you got?
So on that one, real quick. So the reason why we did 11 pi 6 and 7 pi 6 is because it's saying like theta is negative pi 6 from both 360 degrees and 180 degrees, right?
Correct, yeah.
Okay. Because it's in quadrant 3 and quadrant 4 that it could be negative pi 6?
Yeah, so we got the sine of theta was -1/2, so it can be, so sine is negative in quadrants 3 and 4.
Right. Okay.
So it'd have to be in both of those. So it's
Gotcha.
30-degree angle here, 30-degree angle here, essentially.
Okay. Perfect. Thanks.
Okay. All right, what else you got?
$49.
49, I was just going to say one-to-one functions. That should be easy. That's just college algebra, right? You guys remember that just like yesterday. Okay. Let's see if I can copy this. Do I want to copy it here? Sure. 3x squared plus 5. And it says find the inverse. Okay. Now it does say that x is greater than or equal to 0. Why does that matter? Do you guys know?
Is that to make sure we pass the horizontal line test?
That's right, because what does 3x squared plus 5 look like?
A
Parabola?
parabola.
Parabola, right? So if I've got a parabola here, that can't be a one-to-one function because the horizontal line test will cross it twice. And so if I limit my domain to just greater than 0, now it's a one-to-one function. It's a half a parabola. Okay? All right, so what do I do on finding the inverse of a function?
Swap the x and y and solve for y.
Yeah, so we can treat f of x as y. So then I'm going to have x equals 3y squared plus 5.
Then you
So
can
how do I
subtract the
solve for
y,
y?
or you can subtract the 5 over.
I subtract the 5 over, that gives me x minus 5 equals 3y squared.
You divide by 3.
Okay. So y squared equals x minus 5 over 3.
And then square root both sides.
Square root both sides. So y equals the square root of x minus 5 over 3. Now technically it's the plus or minus square root, right?
Mhm.
So how do I decide if this is plus or minus?
With the domain, x has to be greater than 1, so it can't be. Oh, wait, never mind. So then we know that inside the x minus 5, it can't be, has to be 5 or greater, right?
Oh, that's a good point. So your domain is x greater than or equal to 5. Now I don't think it asked you for the domain, did it? But that's good to know. Okay. But my question is, I could put a plus or minus here, right? Plus or minus. So my question is it plus or minus, or can I get rid of plus or minus?
It should be
And why?
plus, right? Because
Should be plus because why?
Because if you had a negative, whatever number you put in for x, the number would always be negative. But it says that there the domain has to be, or the x value has to be greater than 0. So you can't have it equaling a negative number.
Well, so remember these two swap essentially. So the range on the original function is going to be y is greater than or equal to 5. That's your domain here, and then your range here is going to be x greater than or equal to 0. Excuse me, y greater than or equal to 0. Do you understand why? Because I might need to draw a picture if you don't.
I don't think I do.
Okay. So let's talk about this parabola here. Where's the vertex on the parabola?
Would be at it would be at 5.
It would
0?
be at 5, right? So if I were to draw this parabola, let's call this 5. So it's going to be a half a parabola in this direction, right? Okay.
Yep.
Now the inverse function is going to be, if I draw a diagonal line here, this is your y equals x line. It's going to be symmetric about that, and so it's going to be like this, okay? If I did the negative would probably be out this way. And so we don't want this though. This is no good because because we limited our domain to x greater than 0 on the original function, then this piece doesn't matter. We don't want that piece. And so does that make sense? So basically this is f, This is F inverse.
Yep. Yeah, that makes sense.
Okay.
Yeah.
All right. Okay, what else you got?
How about 44?
44. Find all real numbers 0 to 2 pi that satisfy the equation. Oh, we might have a bunch of answers here. Okay. Can I copy this? I'm getting lucky at copying these. Oh, it lost my square root though. 2 square roots of 3. I even copied the 44. I didn't mean to do that. I'll just confuse us later. 2 square roots of 3 sine of 4x equals 3. So how would you do this?
I'm not sure.
That's why you asked, right? Who's sure? I'm going to pick on one of the Camerons because you guys don't ask enough questions. You can tag team on it if you want.
Could you draw a graph?
I could draw a graph, but that would be very hard.
So is it just asking like when x equals 0?
Say that again.
Is it just asking when x equals 0? Like every time the graph hits 0?
Not necessarily.
Yeah, I'm not.
This is really just an algebra problem.
So we need to solve for x.
We need to solve for x.
Then we could divide the sine of 4x by 2 square root 3 and bring that.
So we need to get the sine all by itself. So divide both sides by 2 square roots of 3. Okay. So that leaves me with the sine of 4x on the left side equals, on the right side, I've got 3 over 2 square roots of 3. Okay.
And then you just inverse sine on the left.
Right. Now the problem is, what happens if this number is greater than 1? I got a big problem, right?
Yeah.
Now I could rationalize the denominator. This might help us here by multiplying by the square root of 3. Okay. So that gives me 3 square roots of 3 on the top, and it gives me 6 on the bottom, which is the same thing as the square root of 3 over 2. Well, that was kind of lucky, right?
Yeah.
Because that's a nice angle that I know. Okay. And I've got sine of 4x here. Okay, so if I take my inverse sine,
Yeah.
then I'm going to get a 4x here, right?
Yeah.
Now, where is the square root of 3 over 2?
60 degrees.
60 degrees, and that's the same thing as pi thirds, right?
Yeah.
Okay. So now let's think about this
And
again.
2 pi thirds, right?
Yeah, I was just gonna draw my picture, right? If we go back, do I still have my picture here? Kind of. I've been using this a lot, but so I've got pi thirds is positive in quadrant 1 and 2, right? So I know that's a 45-degree angle, but pretend it's not. So if this is pi thirds, And I got another pi thirds here. What is that angle? I think Tate said it, but I just want to repeat it again.
Yeah, 2 pi thirds.
2 pi thirds. Okay. So this is 2. So maybe I put it or here. 2 pi thirds. 2 pi thirds. Okay. So now I need to divide both sides by 4, right?
Mm-hmm.
So I'm going to get x equals, what's pi thirds divided by 4?
4 pi thirds.
No, divided by 4.
Sorry. Is
Pi twelfths.
Yeah.
Pi twelfths. Pi twelfths, and then 2 pi thirds divided by 4.
1 or pi sixth.
Yeah.
Pi 6. Okay. And, yep, so that would be, wait a second. I get the pi. Is it this one? I don't think that's right, is it? It's not C, is it? 44 is C. Where did we get all those? I got pi 12ths and pi 6.
It's because you have to keep going around the unit circle until. Oh shoot! I can't remember. I remember us talking about it, but it's like every value around the unit circle plugged into that equation that is less than 2 pi, because we're going between 0 and 2 pi.
Yeah, but let me think about this, because I'm trying to think, because it's supposed to be positive. Oh, you know what? Well, I guess there's one way we could do this. If I'd have done this the right way, I probably would have said plus 2 pi k. Plus 2 pi k. And then I would need plus 2 pi k on this one too. 2 pi k. Okay, so this would be plus, so 2 pi k divided, so if k is 1, plus 2 pi, so if I did that divided by 4, so that's plus pi halves. Oh, so that's every 90 degrees. And this would be the same thing.
Open process.
Plus pi halves. Okay, so that's why, you're right. Because this is going to repeat a bunch of times, so then you'd have to figure out, yeah. So pi twelfths plus pi halves is 7 pi twelfths plus pi halves, 13 pi twelfths plus pi halves is 19 pi twelfths. And then pi sixth plus pi halves is 2 pi thirds plus pi halves, 7 pi sixths. Yep. So, wow, that was a tricky one. I would have probably been happy with just the pi thirds, and anyway, I guess you gotta remember that. Okay, oh, you're in the bank now, Corey.
I am.
The bank opened. Not in your hot car.
No.
Okay. Does that make sense, everybody?
Yeah, that
So
makes sense.
on the test, you said we can just write like pi 12 plus pi halves k and pi 6 plus pi halves k.
Yeah.
Or 2 pi k. Whatever it is, yeah. Instead of having to write out.
This is funny because it says 0 to 2 pi. This is probably how I would have done it, but yeah, these are all the angles, because all these angles are less than 2 pi.
Yeah.
But this is kind of the formula. pi 12ths plus pi halves and pi 6 plus pi halves, yes.
Okay.
So that's why they listed them all out there. Okay. All right, what else you got?
Let's do number 14 on review 3.
Review 3?
Yeah.
Number 14. Find the magnitude of the horizontal and vertical components for the vector v with the given magnitude and given direction angle. Round an appropriate number of significant digits. Okay. All right, so I've got a magnitude of 156.1 and a theta of 281.3. So, should we draw a picture?
Yes.
Time for a new picture. Hard to draw that straight. Okay, so 156.1. So my theta is 281 degrees. Which quadrant am I in with my angle?
Fourth quadrant.
That's right. So I'm here, 281, and it probably looks something like this, probably, right?
Yeah.
So my hypotenuse is what? If I were to treat this as a triangle.
156.1.
156.1. Okay. So really what I'm looking for is I'm looking for my vertical component in red. Red, I say. And I'm looking for my horizontal component here.
Okay.
Okay. Now, assuming we don't have multiple choice, how do we figure that out?
Isn't it the 156.1 cosine of 281.3 and then the 156.1 sine of 281.3?
Bang. Here, I'll write that down. Say it again.
So 156.1 cosine of 281.3 to solve for the x, that equals x, and then y equals 156.1 sine of 281.3.
Okay.
No, that was easier than I suspected.
That was easy. And we'd have to plug those in to see which one was the right answer. I don't know that off the top of my head. Well, you can kind of guess. I mean, since it's here, actually, because I've drawn it, I could figure it out based on these. Assuming I get 30.6, 153.1. Which one would it be based on my picture?
See, y is going down, so it would have to be a negative. And then x
So the
would
y would
definitely
have to
be
be
a
negative.
positive.
That would be that one right there, right? And your x is going to be the small number.
Yeah.
So it's got to be
So
d.
that has to be d.
Okay. And I guess we can plug it in. since I still got this here. Just to make sure that we get, let's see, the y should be 153, right? Is this going to work? No, because it's going to be in radians. Let's see, how do I convert that to radians? Actually, I'm going to ask you guys. I've done it a bunch of times. You should remember. How do I convert that to radians?
180 over multiplied by 180 over pi.
No, is it 180?
Indeed.
Isn't it pi over 180?
Pi over
'Cause
180.
281
Sorry.
is the- yeah.
Yeah, that's right. Sorry, my
Okay.
bad. Because I got degrees on
That gives me
top.
negative
Then degrees on top.
153.07. Bang. So that's
Yeah.
good. Okay.
I remember
All right.
that. Degrees on top, degrees on bottom. Bam.
Okay, what else you got?
Can we go over number 38 on review 3? I just always get confused with this one. So it talks about finding the product or quotient using the trigonometric form.
Okay. So how do we do this one? Are you going to let me copy?
Are we
Foil
changing
it.
each of those? So we're not changing those into the trigonometric form first and then foiling it?
That's a good question. It would be much easier just to foil that, right?
Yep.
Yeah.
But it does say to use the trigonometric form. God, that's dumb.
So
I'd
that's
rather
where I
just
was-
foil that.
Okay.
But because that would be so much easier, right?
Yeah, because then you have to
It's
change
easier
it into
not to convert that
form,
to trigonometric form.
and then solve it and then change it back into a plus
Yeah,
bi.
that seems kind of dumb. I don't know. The only reason you'd have that problem is just to show that you could do it, because it doesn't make any sense to change that to trigonometric form and then change it back.
That's fine. Okay.
Other than to show how smart you are.
Sounds good.
What about the following problem, number 39?
Number 39 would also be dumb to change it to trigonometric form. It would be much easier just to leave it as is. So, seriously, changing this to trigonometric form is much harder. How would you do this without changing it to trigonometric form? Let me ask that question.
Multiply it by 9 minus 3i.
Right,
on
multiply
top
by
and
the
on
constant.
bottom.
Yeah.
And then you just do full on the bottom and then foil on top.
Right.
Oh, easy.
Yeah.
I remember doing that.
But not so easy doing it in trigonometric form.
Yeah.
And that just, I mean, we can do it. Do you want to do it? It's up to you.
No.
It
I'm
just
good.
seems
That
silly
makes,
to do this, to change it
Yeah.
to trig and then back.
it makes sense. Just
Okay.
to do it in the one form. So
All right, what else you got?
Just a real quick question. Trigonometric form is the magnitude and the angle, right?
Right.
Okay.
and can we just go over like even if we just change like numbers 38 into trigonometric form, can we just go over that real quick just so I can remember not solving it but just changing it?
So do you want to just change the first part?
Yeah.
6 plus 8i. So how would we change 6 plus 8i to trigonometric form?
So the magnitude is the square root of a squared plus b squared. So the square root of 36 plus 64, which would end up being 10.
Yeah, that was kind of lucky. So that's 10.
And then the tangent of theta is equal to the absolute value of b over a.
So 8 over 6.
8 over 6, yeah.
Yeah.
Which is 4/3.
And then you would inverse, or you could just inverse tangent that to get the degree.
It's not one we know though. Inverse tangent.
No. A tangent of 8, 6, 3/4.
Or 4/3.
4/3, that's right.
Yeah, that's an ugly angle. This is really way harder to do in trigonometric form. Times 180 over pi.
Over pi, yeah.
That's awful. I don't know why you'd do that. That's just way harder.
You see, then you get 10, 53.1 degrees, and then they're asking you to then FOIL that out and then put it back into a plus bi. And so when I was doing the review, I got super confused. I'm like, that makes no sense to just change it.
Yeah, that's just a really hard way to do this problem, and it doesn't make any sense. I don't think I would ever do that. Okay,
sounds good.
And you know, I am kind of a sadist, but I wouldn't make you guys be that awful. Okay. All right, what else you got?
Number 6 on review 5. Or sorry, 4. We don't have review 5. Review 4, which is the 6.5.
Oh, this new one here? The one I just posted this morning?
Yeah.
I'm impressed that you're looking at it. 6. R squared equals 22 cosine 3 theta. Oh, I probably shouldn't have put that one on there. It looked nice. I didn't look at that one very closely. So we got, I was thinking, it's going to be rose petals because you got 3, right?
Right.
And it was an R squared. So why is it R squared? I didn't look at this one very closely. I shouldn't have put this one on here. So it's got to be 3 petals. It's cosine. So when cosine of 0 is 1, right? Yeah. So if we're looking at 1, and we got to be 22 squared units out. So what's the square root of that? That's about 4.5.
So it'd have to be C?
It'd have to be C. Yeah. C's in the right orientation, and it's the square root of 22.
Okay. That makes more sense.
Okay. I shouldn't have put that one on there. Why did didn't notice it was an R squared. I thought it was an R. Okay. Any others?
Number 12.
Graph the pair of polar coordinates on a calculator. Oh, why did I put that one on there? I see I didn't look very closely. I should take those 2 off. And use the trace feature to estimate. Oh, see, I didn't. Well, how would you do this without a graphing calculator? This is actually, but this is, you don't ignore those directions. You can solve that without a graphing calculator. That's why I didn't notice it said a graphing calculator. You do not need a graphing calculator. I should take that off there. You should be able to solve this polar coordinates without a calculator at all. That's why I put it on there. I didn't notice the directions said the graphing calculator. This should be really easy to solve without a calculator, in fact.
you just plug in numbers? I mean, like 0 in for sine and for theta.
No, you've got two equations. So you got equation r equals 6.
Yeah.
So let's think about that for a minute. What does r equals 6 in polar coordinates look like?
Yeah, it's a circle with the radius being 6.
That's correct. Okay. So we're using polar coordinates this time instead of rectangular coordinates. It'd be nice if I had a polar coordinate thing, but I don't. But this is a circle centered at the origin of radius 6. Okay. Now, this is 6 sine theta. What does that look like?
That looks like
Oh,
a
that's
dimple.
a.
It would have a dimple on it, right?
Right. A limicon?
Yeah, limicon. Well,
Okay,
actually, I
can't
looked up
tell
the
them.
pronunciation. It's a limicon.
I've always heard
anyways.
it a limicon. My my trig teacher called it a limicon, so I'm going to call it a limicon.
Okay.
Would it just be a convex limicon with no dimple because it's a over b is greater than or equal to 2?
Yeah.
Okay.
But this is really easy to solve. In fact, you don't even really need the picture on there, other than I'm glad you knew that was a circle, and I'm glad you knew that was a limicon. You want to know where they equal? Let's set them equal to each other.
Oh.
Okay. So 6 equals 6 plus the sine of theta. How do you solve that?
Subtract the 6
Okay.
on the
We
right
get
side.
0 equals the sine of theta, right?
Yeah. Take the inverse sign on both sides.
Okay. So theta equals.
It could be
It'd be
t sine is y on the y-axis, so it could be at 0 or
pi.
pi.
That was.
Oh, bam. Nice.
You really didn't even need a picture for that. And since I can't draw a limicon, but here I'm going to do my best. Let's draw this limicon here really quickly, okay? And but the idea here I'm going to tell you what the answers are right here. I'll use red here. The answers are going to be, oh, I didn't mean to do that. That's okay. Now I'll go back to black. Now I'll go to green. The answers are going to be, it touches right here and it touches right here. Okay. Now, just for practice, let's draw this limicon. Okay. And probably the easiest thing to do are to find the sine of 0, sine of 90, sine of 180, sine of 270. Okay. Sine of 0 is 0, right?
Yep.
So this is going to be at 6. Okay. Sine of 90 is
1.
1. So 6 plus 1 is 7. So if I were to draw, I'm just going to draw a little tick mark here. That's about 7. Okay. Sine of 180 is
0.
0. So that's going to be right there again. So I've got 1, 2, 3 points. And sine of 270?
-1.
-1. So that's going to be right here, right?
Yep.
And so this is so essentially I'm going to be going, whoops. I'm going to be going through something like this. So I've got a limicon on top of my thing. I was thinking it was going to have a loop, but it's not going to have a loop. And it's going to cross right here at these 2 points. Well, here, let me make sure my graph is really good. Let's go to Wolfram Alpha. That's weird. Should use a real thing. Wonder why it did that. Okay, graph R equals 6. R equals 6 sine X. Oh, polar coordinates. Oh, it doesn't like that. I've never tried. That's the first time I've ever tried that.
You tried using Desmos and see if it does it.
Theta.
It's supposed to be 6 plus sine.
Oh, you're right. 6 plus sine. That's what I did. No, it doesn't like that. I've never tried to do polar coordinates on that. That's funny.
You try Desmos and see if it does it.
Desmos?
Yeah.
I haven't tried that one. Let me get rid of that and see what it does. Maybe if I put an X here. No, it wants to use rectangular only. That's weird. Huh, I thought that would do that. I'm surprised. Oh, well, never mind. You'll have to just trust my picture's good. Okay. What else you guys got?
Let's see. Number 3.
Same one? Convert rectangular, or convert to rectangular.
Yeah.
Okay, how do we do that?
Wouldn't that be... Oh, sorry, Jeopardy. Goodness. So, let's see. We know R and we know theta. So
equals the square root of 3.
Right.
And theta
equals
pi
pi
6.
6. So in
Okay.
order to find x and y, we could do x equals square root of 3 cosine pi 6.
R cosine theta, right? And y
Right.
equals
R
r
sine theta.
theta. Okay.
Yeah.
So this is going to be the square root of 3. And the cosine of theta is?
Cosine of pi 6 is... I keep on thinking in terms of degrees. Pi 6 is
30 degrees.
30 degrees. So then
The
that
cosine
would
of
be
30 is?
square root of 3 over 2.
Square root of 3 over 2. We'll simplify that in a second. And this one's going to be the square root of 3 times, what's the sine of 30 degrees?
That'd be 1/2.
1/2. Okay, so the x coordinate square root of 3 times square root of 3 is 3 over 2. And this becomes square root of 3. Oh, that's funny. Square root of 3. 3 over 2. Okay.
Okay. Which is D.
So it's D. Yeah. Okay.
How did you do it the other way around, like 4? We know X and Y, but we don't know R and theta.
You want to do 4?
Yeah.
Who would do that one? What's the formulas we need to remember?
Square root a squared plus b squared.
You're really soft. Say it again.
Square root a squared plus b squared.
How about the square root of x squared plus y squared?
Oh, that one works too.
These aren't really a and b, they're x and y, right?
Yeah, but it would have been the same answer.
yeah, it's the same answer. But yeah, so this is your x and that's your y. And then theta is?
Be the inverse, or sorry, the tangent of y over x.
Okay. So in this case, I've got, this is going to be the square root of, I'm going to do the y first because that's going to be 4, right? That's easy. 2 squared is 4. Plus 2 squared is 4. Square root of 3 square root of 3 is 3. So 3 times 4 is 12. Oh, that was lucky. So that's the square root of 16, which is 4.
Yep.
And your inverse tangent is?
It would be oh wait, sorry, it's y over x. It would be 2 over 2 square root of 3. And if we rationalize the denominator, it would be,
The 2's cancel, right? So it's 1 over the square root of 3.
yeah,
Which is the square root of 3 over 3.
which is
What angle is that?
60 degrees. No, sorry, 30 degrees.
30 degrees. 30 degrees. So that's answer A.
I was thinking 60, but I was like, wait a second, that's square root of 3, not 1 over square, or 3 square root of 3. 3 square root over, yeah, whatever.
All right. Well, I think that'll be our last one because we're about out of time. Do you guys have any questions on the test? Oh, Brian, you showed up. Welcome. We got a few more people showed up. Any questions about the test tomorrow?
Are you going to do the same thing with the calculator, like have it a part of the test like last time?
Yes.
Cool. Thanks.
If we have issues with the online calculator, can we use our own? Because there were a few people that had issues with the online calculator.
Well, so what were the issues? Because the issue, I mean, it's just a simple calculator there.
Yeah, but for some people, it just stopped showing up. Like they would try clicking on it and the calculator wouldn't show up.
Oh, really?
Yeah. I think Jackson had that issue where he got like halfway through the test and he tried kicking.
So it was working for part of the test and then it quit working?
Yeah.
Is that what happened?
Yeah.
Really? Oh, that's weird. Here's the weird thing. I used to have, so the last time I taught this class was a live class, and I used to be like, okay, first part you have to have with no calculator, second part you have to have a calculator. And so they would turn in the first part, and then they could use their calculator for the second part. Obviously, that's going to be very hard to do, but I'd prefer that most of it was done without a calculator. And then I'm wondering, should I just make it a no calculator test? Does that make it easier?
No.
It doesn't make it easier?
I mean, I'd like to use a calculator, honestly.
Yeah. I like to check my answers.
Because I still haven't written the darn thing. I would prefer you use the online thing. I'm going to try to be flexible because I know there's tech problems, but I'd prefer that you use the online calculator.
Okay.
And if you use the other one, show me your calculator. Make sure it's not an illegal calculator.
Okay.
Because you can't have any graphing calculators. That's part of the reason I do this.
Okay.
And I'm sorry, I didn't look at the directions closely on the review to see that last one. Just so that use your calculator, but that one you didn't need a calculator for. That was why I picked it, because I was like, oh, that's easy. So, all right. Okay, so just a reminder, quick reminder, 2 hours. The test will be 2 hours, so it'll be slightly longer than the normal ones. Still have to post it within a half hour of. So basically, it's 8 to 10. Have to post it by 10:30. There's a few people that are exceptions to that, but I won't address that. But yeah, it'll be just like all the other tests, only a little bit longer. So.
Sounds good.
Okay.
Thank
All
you.
right. Well, good luck. It's been great having you. I hope you're all staying healthy and avoiding the coronavirus. I know we've had a few people that have not. So, and if you're taking statistics next semester, I'm teaching 3 stat classes. So, anybody taking statistics?
I'm taking calculus next semester.
Oh, that's all right. Well, if you do, it'll be a fun class, but it'll be online again. So.
Maybe I'll see you
all
on
right.
campus one day.
Yeah, maybe. Yeah, maybe. Did you guys hear the Pac-12 and the Big Ten canceled their? Well, not canceled. They're moving football to spring.
I have not.
I had heard that about Pac-12.
Yeah. Yeah, Big Ten, Pac-12. So I don't know. I don't know if there's going to be football this fall. So. All right. Well, people are dropping off. I don't want to be hearing about my football, I guess. So stick around for Texas's study group, and good luck, and I hope you do awesome on the final.
Thanks.
Thanks.